Hello everybody, this is Miss Barber here with another exciting lesson in Algebra 2, Lesson 6.4. We're going to learn how to factor. I'm going to make two videos. The first one is going to be on factoring the sum and difference of two cubes pattern. So there's going to be some formulas we're going to need to know for this. So let's go ahead and take a look. The first two formulas we're going to be learning today, or the only two in this lesson, is going to be the sum, aka we're going to have a plus, because that's what sum means, of two cubes, meaning numbers that are multiplied by themselves 3 times over. So 2 times 2 times 2, or 2 to the third, which is 8. So in order to do the sum or difference of cubes, similar to what we did in the only in the difference of squares in chapter 5, is we're going to need to take the square root, or the cube root, as opposed to the square root, because these are cubes, the cube root of both a cubed and b cubed. So we're going to take the cube root of a and the cube root of b cubed. The cube root of a cubed is just a, and the cube root of b cubed is just going to be b. And this is the a and the b we're going to be using in our formula. So here is my first formula. A cubed plus b cubed is going to factor to a plus b, so the cube root of both, times a squared minus ab plus b squared. Notice, and this is very important, we started with a plus. This was the sum. So you're going to see a plus in the first set of parentheses, a plus b. But then the next time we need a symbol, it's going to be a squared minus ab. And then it is going to end with a plus, as it always does. So that is for the sum. Now, what if I have the difference, a cubed minus b cubed? The formula is going to change slightly because of that minus. So instead of a plus b, it's going to be a minus b. But then because I have that minus to start, everything from here on out will just be plus. So a squared plus ab plus b squared. So effectively, we're doing the same type of work for both problems, but our signs are going to change depending on whether I am adding a cubed and b cubed together or subtracting them. So just please make sure you always are paying attention to your signs. Those are the two formulas that you're going to always want to make sure you have readily available. If you write them down every time, you might even get them memorized before the end. Let's go ahead and try number example 1a. Factor the following polynomial, x cubed plus 1. Let's zoom on in here. Again, I'm going to need to take the cube root of both to find my a and my b. The cube root of x cubed is just going to be x. And the cube root of 1, which is going to be my b, is just 1. Hopefully you see 1 times 1 times 1 is 1. So 1 to the third is 1, so the cube root would be 1. But if you're not that familiar with your cube roots, on your calculators, on our graphing calculators, if you press the math button and then scroll to number 4, that's where you would see the cube root symbol that you can type in numbers to find the cube roots. Remember, you can never do variables, only numbers on calculators unless you are graphing. Okay, so now I'm left with x cubed plus 1. I took the cube root. I'm just going to rewrite the formula. Again, the more you write it, the more likely you have to have it memorized. So this is the formula from above. Now I'm just substituting in my values for a and b. A we said was x and b was 1, the cube root of both, times a squared, so x squared, minus 1 times x, which is x, plus b squared, which is 1 squared, which is just 1. So once you have substituted it all in, if you don't have anything else to simplify, then this is simply your answer. This is how you factor the sum of cubes. Let's try another one. So following the same pattern in letter B, again, I'm going to need to take the cube root of both. My first is the cube root of 125, which is 5. Cube root of x to the third will just be x. Again, the math button, number 4, which is the cube root, will help you find the cube root of 125 if you don't know. The cube root of 8 is 2. 2 to the third is 8. So my a and my b are 5x and 2 respectively. We're going to use the same formula from before. So I could write it down. A plus b times a squared minus ab plus b squared. And then let's substitute it in. A is 5x and b is 2. So it's 5x plus 2. Now a squared. What you should probably do is put this in parentheses as 5x squared, because not only do I want to square the x, I also am going to be needing to square the 5. Minus a times b, which is going to be 5x times 2, plus b squared, which is 2 squared. You won't ever have to simplify anything in your first set of parentheses, so that's just going to be 5x plus 2 again. Simplifying things in my second set. 5 squared is 25. X squared is just x squared. So distribute that 2 to both the 5 and the x. 5 times 2 is negative 10 x. Obviously, I'm at school right now. 7th period just ended. And then lastly, 2 times 2, or 2 squared, is 4. So this is my final answer. This is what we are looking for if we ask you to factor a cube. We do need everything to be simplified. You shouldn't be leaving 2 squares or any numbers to any power left unsimplified. Let's try a few now with minus, or the negative. So let's look at letter C. Notice now we have a minus in between. The negative, or the subtraction, is going to be impacted by the formula. So now this formula, because it's minus, is going to be a minus b times a squared plus ab plus b squared. When I take the cube root, I still am taking the cube root of both parts individually and not including that negative sign. So it's not negative 216 I'm taking the cube root of, it's just 216. Again, the minus is taking place, or the subtraction is taking place in the formula. The cube root of x to the third would just be x. And the cube root of y to the 9th is actually going to be y to the third. Because 3 divided by 3 is 1, which is x to the first. 9 divided by 3 is 3. So you're always dividing by 3. That's how you take the cube root of variables with exponents. And then the cube root of 216, which is my b, will be 6. So now we can go ahead and substitute these values in, a and b, into my formula. So it's going to be x y to the third minus 6 times x y to the third squared. Notice how I put that in parentheses like that, knowing I got to distribute, times x y to the third times 6, a times b, plus 6 squared. Again, just substituting in a and b. Now we just have to make sure we simplify as much as possible. X y to the third minus 6 just stays. Now for my a squared, I have to distribute the 2 to both using multiplication, so it's going to be x squared y to the 6th, plus, for this middle term, we usually write the number, the coefficient in front, so it's going to just be x y to the third, plus 6 times 6 is 36. So this would be my final answer. Again, everything that's simplified that can be. Let's go ahead and try one more before we add another complication to this whole fun day. So let's look at letter D. So here for letter D, again, I'm left with a minus sign on the in between my 2 cubes. So I know I'm going to be using the formula a minus b times a squared plus ab plus b squared. And I'll be taking the cube root of both. The cube root of 27 is 3, and the cube root of x cubed is just x, and the cube root of y to the third is just y. So my a is 3x and my b is y, so I can substitute that in my formula. Again, you're not taking the negative into account when you're taking the cube root. It's just part of the formula and which one you're going to choose. So it's going to be 3x minus y times 3x in parentheses squared plus 3x times y plus b squared, which is y squared. The only thing that needs to be simplified is this 3x squared, so let's go ahead and do that. Remember, this is 3x minus y again, and my squared needs to be distributed to both the 3 and the x squared. So it's going to be 3 squared, which is 9x squared plus 3xy plus y squared. And this is your answer. Okay, so as promised, I said we have to add a slight complication to it, and that is what we also added in Chapter 5. You might remember in Chapter 5 that the first rule of factoring is to always pull out or factor the GCF. Those last 4 examples did not have a GCF, so that's why I didn't talk about it, but I would be remiss if I didn't mention that lots of problems can have GCFs, and you need to make sure that you are factoring and dividing them out. That will always be your first step in factoring. So we might not always remind you to do it, but you do always need to divide out, check to see if there is a GCF, and if there is one, divide it out. So let's look at a couple of problems that have a GCF. So in example 2a, I notice that there's a 10 in both and an x. So I know my GCF is going to be 10x. So I can divide out a 10x for both. X to the fourth divided by 10x is just x to the third. And 10x divided by 10x is 1. So now inside my parentheses here, I have the difference of perfect cubes. So using the formula on the front page, I'm going to need to take the cube root of both and then follow the formula for the difference of cubes. The cube root of x to the third would be x, and the cube root of 1 is 1. So following the pattern, it's going to be x minus 1 times x squared minus x plus 1 for a squared minus ab plus b squared. And this little 10x, the GCF, it's like your little sibling you took to the mall. You can't forget about them. They need to make sure that they make an appearance at the beginning of the problem when you are finished, because we divided it out, but it's still there. So if I was to redistribute the 10x, the x minus 1, and the x squared minus x plus 1, I would end up back at my original problem of 10x to the fourth minus 10x. All right, let's take a look at letter B. This time, my GCF is 2x because 2 goes into 54, and they both have an x. So I could divide out a 2x, and I'd be left with x to the third plus 27. Again, this in parentheses is now the sum, because this is a plus, of perfect cubes. So I can take the cube root of both and factor just like we did for the other 5 problems. The cube root of x to the third is x. The cube root of 27 is 3. So my a and b are x and 3. So it's a plus b, x plus 3 times x squared minus 3x times 3, which is 3x, plus b squared, which is 9. I'm kind of skipping the step of writing down what I'm squaring. Hopefully at this point you've caught on. And then lastly, my 2x, my GCF friend, can't leave him behind, goes out in front. So that is the completely factored version of 2x to the fourth plus 54x. While I'm here, might as well do letter D. It's right below it, so let's just take a look at letter D. There's a GCF because there's an x and 3 goes into 24. So I can divide both by 3x, that's my GCF. Dividing both by 3x, I'm left with x to the third plus 8. Again, what's in parentheses is the sum of cubes. So I can take the cube root of both x to the third and 8. The cube root of x to the third is x, and the cube root of 8 is 2. So factoring x cubed plus 8 using the formula is going to be x plus 2 times x squared minus 2x plus 2 squared, which is 4. And then again, my factor friend, 3x, goes out in front. So that is my final answer. That is factoring the sum and difference of cubes. Notice whenever I divided out the GCF in all of these, my final, or what was in parentheses, had 2 terms. So I had x cubed minus 1. I had x cubed plus 27. I had x cubed plus 8. They were cubes, and there was only 2 terms. Let's look at letter C now. I can divide out the GCF. In this case, the GCF would just be x. They all have an x. If I divide out an x, I'm left with x squared plus 2x minus 3. Now, what is in parentheses? First of all, it has 3 terms, not 2. It's a trinomial. And there's no cubes, so I'm not going to be using the sum or difference of cubes formula. But instead, whenever you're given 3 terms, specifically when you have something to the second power, this is a quadratic, we use the x method for factoring. Remember, it's ax squared plus bx plus c. In this case, my a is 1 because it's 1x squared. So on the top, I do c times a, which is 1 times negative 3, which is negative 3. And my b is 2. On the top, I'm going to write 1x or just plain old x because it's ax. And I'm looking for 2 numbers that multiply to negative 3 that add to positive 2. Those 2 numbers are 3 and negative 1 because 3 times negative 1 is negative 3. 3 plus negative 1 is 2. So this is going to factor to x plus 3 and x minus 1. If what I'm doing is very confusing to you, I highly recommend you go back into the Chapter 5 folder and look at the videos from 5.3. This is where we learn to factor these things. In the next section, which is section 6.5 and then also 6.6, it's assumed that you know how to factor these. So again, 5.3 video if you need more help. And so x squared plus 2x minus 3 factors to x plus 3, x minus 1. And we can't forget about our GCF friend, the x out in front. So even though this started as a trinomial, or as a cubic, x to the third, I did not use the sum or difference of cubes pattern. So please always make sure you pay attention, count the number of terms, and determine the best way to factor. That's it for learning how to factor the sum or difference of cubes. I hope you learned a lot today, and I hope you all have a beautiful rest of the day. This has been Miss Barber for LHS Algebra 2. Goodbye.